All right, so welcome to a new project, and in this project, my plan is to build a do-it-yourself stereo power amplifier using LM1875 modules ordered from eBay. Why I'm doing this, that's a good question and one that's not simple to answer, but there's basically two reasons. One is Jan Beta did a video recently where he built a stereo amplifier using modules from eBay, and it really made me realize how inadequate my sound system in my office is. It was just a couple of crappy computer speakers, so I would like to have better audio playback for my bench. And my rough goals for this project are I would like to have something reasonably loud through a good set of speakers, something on the order of 5 watts per channel with good sound quality. And I would like to do this reasonably inexpensively, meaning I would like to use mostly parts that I already have. I have ordered the LM1875 modules from eBay, but those are super cheap. They're like $3 each. And they should be capable of producing up to 20 watts per channel, although I certainly do not have ambitions to drive them that hard. Okay, so basically what's going to happen today, or at least in this video, is working on the power supply. So the LM1875 requires a split rail supply with both a positive and negative symmetric voltage rails. And the most straightforward way to do that is to use a center tapped transformer. And luckily, I do have one of those. And you run that through a bridge rectifier, you add a couple of voltage regulators, and you should get a nice, stable positive and negative output for powering the amplifier modules. Oh, and just a word of warning, this is not going to be a scripted video. It will be somewhat off the cuff. I literally have not started this project yet, so you will see the design process, and you will also probably see me making a lot of stupid mistakes because I don't know anything about analog electronics, but hey, you gotta try stuff, so let's get started. Well, before we go any further, let me just be explicit in mentioning Jan Beta, whose video inspired me to start this project, and also John Audio Tech. His channel is absolutely fantastic if you're interested in audio tech, and it was watching one of his videos where I got the idea to use these LM1875 modules because he had a very favorable review of them. Okay, let's go. All right, so here's our basic unregulated AC to DC power supply. So the idea is that our AC mains current that's coming in from our wall plug goes through a transformer, which steps it down to a lower AC voltage. So our 120 volt US house current gets stepped down to a lower AC voltage. The particular transformer I'm using will step it down to about 24 volts AC, but because of the center tap, we can actually get half of that stepped down AC voltage, so basically 12 and 12. This lower voltage AC power signal is then fed through a bridge rectifier that essentially gives us just the positive peaks of the signal. And basically, this is something that's not exactly a DC voltage, but is closer to a DC voltage, and essentially by feeding it through smoothing capacitors, we can basically take this very choppy, rectified signal and turn it into something that's closer to a smooth DC signal, although there's still going to be some ripple that the capacitors won't remove. And so I think the basic idea that allows this to be a split supply is that we have the center tap of the transformer. We'll consider that to be our ground reference, and we connect that ground reference between these two symmetric smoothing capacitors. And I think basically the idea is that this is going to give us a reference that's sort of halfway between the peaks of this rectified signal, meaning that we should get about the same potential here as we get here. And that essentially is what creates our split rail output, with the center tap being our 0 volt reference, and we should get a positive voltage and a negative voltage out of the circuit. Again, it's not going to be completely smooth, but we'll deal with that in a second stage of the power supply, which is our regulation. All right, now that I'm thinking about the fact that I am describing a power supply that takes mains voltage from the wall, I need to emphasize really strongly that if you are considering building circuits that use mains voltages, you need to be extremely careful and know what you're doing. And given my status as a relative novice at analog electronics, and in particular power electronics, you should not ever assume that I am correct. So anything that you take from this video, please independently verify and do your own research, and just be really, really careful. Mains voltage can kill you, so please take that under advisement. All right, so here are some of the components that we will need for the power supply, and I have them on this scrap piece of plywood that I'm going to use as the base for the amplifier housing. So there's an IEC connector where the wall plug will come in. The ground will go into one wire on the primary side of the transformer. The live wire will go into a fuse, and then into a toggle switch, and then from there to the other wire of the primary, and that's how the mains current will be delivered into the primary side of the transformer. These are the 3 wires for the secondary, which will come into screw terminals on the circuit board. Here is our bridge rectifier. I have a couple of 3300 microfarad electrolytic capacitors that will be the smoothing capacitors. I have not yet sort of planned out where the voltage regulators will go, but basically they will go on this side of the circuit board so that I can put a big heat sink here just to make sure that the voltage regulators can adequately dissipate heat that's generated in regulating the voltage that's coming out of the filter capacitors. And then over here I will have more screw terminals that will basically deliver power to the other parts of the whole setup that need it. There will be 6 of the screw terminals that will feed ground, negative voltage, and positive voltage into our 2 amplifier modules. Basically, all of the amplifier circuitry will go over on this side of the enclosure, so that I can put the amplifier modules here with again some reasonably large heat sinks to make sure that the amplifiers can dissipate heat that's generated as they're driving the speakers. Speaker terminals will go back here. I think I'll have the audio in probably back here, and then this is the front panel. There's not really going to need to be a lot here. Certainly there will be a volume knob, and probably just an LED so that I know that it's on. Okay, so now my plan is to wire up the mains connections and the voltage, the bridge rectifier, and the smoothing capacitors. And basically, I just want to see what DC voltages I get after rectification and after the smoothing. Alright, so I have the IEC connector wired through the fuse and the switch into the primary side of the transformer, and I have the wires from the secondary side of the transformer just connected to this terminal strip at the moment, just so I can test the AC voltages that I'm getting from the secondary. Alright, so I am going to very carefully flip the switch. So now that is feeding the mains current into the primary side of the transformer. And if I probe from the center tap of the transformer onto each side, I see an AC voltage. Okay, so I've got 13.4 or so volts AC on one side. Let's see, 13.4 volts on the other side, and across the entire winding on the secondary side, I should see the full AC voltage, so 27 volts AC. So because there is no load connected to the secondary side, this voltage will decrease a bit when there's a load on it, but it should be good for some substantial part of the AC voltage. All right, so the next step is to wire up the circuit with the bridge rectifier and the smoothing capacitors, and then see what kind of DC voltages we get out. One thing I'll mention really quickly is just to note that I generously used heat shrink on the terminals where there was going to be mains voltage, so that should provide some protection from, touching a live mains current. But in general, I can't emphasize enough, you need to be super careful when you're working with mains voltage. Okay, so I have on this protoboard wired up the bridge rectifier and the two smoothing capacitors, and I'm feeding in the 3 wires from the secondary side of the transformer. And now what I would like to do is measure the DC voltages relative to this 0 volt reference point provided by the center tap of the transformer's secondary. So this is going to be easiest to measure on the other side, the bottom side of the circuit board here. Okay, so I'm very carefully going to apply power. All right, so basically, right, this is the ground point between the two smoothing capacitors. Okay, so this should be our negative side. Okay, and I'm getting, about negative 18 volts. I'm curious to see what the AC voltage is. That should essentially tell us sort of the ripple. Wow, 0. Okay, I don't think that's right, but okay, good. So we are getting a good negative voltage. So this should be our positive voltage over here on this side, and we get a little over 18 volts. Okay, so that's fantastic. Looks like our circuit so far is good. The next step is to add voltage regulators so that we get a steady voltage on each side, because as the load varies, these DC voltages, unregulated DC voltages are going to decrease, so the voltage regulator should give us a more of a steady voltage. All right, so let's work on that. All right, so one issue to be aware of when you are building this type of power supply with these large smoothing capacitors is that these can hold a charge for a significant amount of time after power is no longer applied to the circuit. So right now the switch is in the off position, so there is no mains voltage going into the transformer, but we still have nearly 18 volts across the terminals of this smoothing capacitor. So one thing you can do is to use a power resistor to discharge the charge of the capacitor. So if I connect the other alligator clip to this capacitor, the voltage now drops back to 0 because it's essentially been discharged through the resistor. So it's a good idea just to be aware that these big capacitors can hold a charge, and you really don't want to touch the terminals. That would, while it's charged up, that would not be a pleasant experience. All right, so the way we are going to do voltage regulation for the positive voltage rail is to use an LM317 voltage regulator. These are fairly straightforward to use. You feed in an input voltage, it will spit out a regulated output voltage, and the way that the output voltage is determined is by setting up a voltage divider consisting of two resistors, R1 and R2, and the middle of that voltage divider is fed into an adjustment pin on the LM317. And the way that the voltage divider sets the output voltage is according to the formula. The output voltage is 1.25 times 1 plus R2 over R1. And if you rearrange that formula a little bit, you can solve for R2. So in the way that I am planning to set things up, I'm going to have R1 be equal to 510 ohms. That's a common resistor value. And R1 is apparently needs to be in the range up to 1K. You don't want R1 to be larger than 1K, so 510 seems like a good value. So if we want the maximum voltage that is going to be produced by this LM317 to be 15 volts, then R2 should be 5,610 ohms or thereabouts. And however, I'm not exactly sure what I want the output voltage to be. It kind of depends on how the DC output of the transformer changes as the load varies. And so I may want to pick kind of a conservative output voltage that I know that the transformer can reliably produce. And so what I really want to do is have R2 be an adjustable value so that I can change the output voltage. And so my plan is to make R2 a 620 ohm resistor in series with a 5k ohm trimmer potentiometer. And so by adjusting the potentiometer, I can essentially adjust the output voltage up to 15 volts. And so that should allow me to choose an appropriate output voltage. Okay, so that's the positive power supply rail. To do the regulation for the negative power supply rail, there is a similar device called the LM337, which is very, very much like the LM317. It even uses more or less the same formula for choosing the output voltage. However, it is a negative voltage regulator. So if you feed an input voltage that is below ground, it will produce an output voltage that is also below ground. Okay, so the next step is to create a test circuit using an LM317 just to verify that if I arrange things in the way that I have planned, that I can adjust the trim pot in order to set the output voltage. All right, so let's see if that works. Okay, so here's our test circuit with the LM317. It's being fed from 18 volts from one of my power supplies, and I have the trim pot set all the way to its lowest resistance, essentially zero resistance, and we're getting about 2.8 volts output. And obviously this is much lower than would be useful for an amplifier. But it's fine. You know, the goal is to produce up to 15 volts. So what I'm going to do is I'm going to adjust the potentiometer to increase the resistance, and so we should see the voltage increase. All right, so I'm going to adjust that, and I will resume when we have a higher voltage. Do 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 do. All right, so I have adjusted the trim pot to increase the resistance to the maximum value, and we've maxed out at about 14.5 volts. That is totally fine. That's close enough for my purposes. I'm thinking probably we will want the voltage rails to be, 11 volts, 11.5 volts, plus minus, something like that. Okay, so that looks good. I think that's a good proof of concept for the LM317. I am now going to try an experiment with the LM337 to see if we can appropriately regulate a negative voltage. So let me swap that out and try again. All right, so here is the smallest negative voltage we can produce using the LM337. It's about 2.8 volts, so that's fine. Doesn't really matter. We just want to be able to go down to about negative 15 volts. One kind of strange thing about the LM337 is that the pinout is different than the LM317. Specifically, the input voltage and output voltage pins are reversed, so I had to change the breadboard slightly here, but it's fine. Okay, I'm going to increase the resistance, and we should see this voltage decrease down to something close to negative 15 volts, so I'll come back when I've adjusted that. All right, so here is the most negative voltage we can produce with this setup, which is negative 14.78 volts. So that's great. That's about what we were shooting for. Again, this is from a negative 18 volt supply coming from one of my bench power supplies. So this is all good. I think we have a viable approach for adding the voltage regulators. So the next step is to actually put those on the proto board and wire them into the circuit so we can produce the regulated supply rails from our power supply. So, okay, let's do that. Okay, I have wired the 2 voltage regulators onto the proto board, the LM317 and the LM337. I did make one change, which is the voltage divider that I'm using to select the output voltage from each regulator. Instead of using a 620 ohm resistor in series with a 5K trim pot for R2, I'm instead using a 1.5K resistor in series with the 5K trim pot, meaning I can adjust R2 up to about 6,500 ohms. And essentially all this does is allow me to generate sort of a more useful range of possible voltages. Now it's going to be from about 6 volts to about 17 volts, and I'm confident that a good voltage to drive the amplifier modules will be found in that range. I wanted to go a little bit higher, or at least have the option to go a little bit higher than 15 volts. And I did test that on the proto board first to make sure that it worked, and it does. Okay, so let's see. So let's turn our amplifier power supply on and test the output voltages. So basically these screw terminals are where the output voltages appear. This is ground, plus minus ground, plus minus ground, and plus. So basically these 3 are for one module, these 3 are for another module, and then this ground and positive is just going to power the LED that I can use to indicate that power is on. So let's test our voltages here. So here's the positive voltage. I've got it set at 14 volts. I could adjust that higher or lower. This is the negative voltage. I've got it set at negative 14 volts. Again, could be higher or lower. So that's great. I'm still not sure exactly what will be the right positive and negative voltage to use for the amplifier modules, but I am confident that the power supply board is working well at this point, and I guess I just have to now wait for the amplifier modules to show up, and then we can actually maybe start playing some music. All right, I am going to tentatively say that the power supply works at this point. The next step is to assemble the LM1875 modules once they arrive. According to eBay, they're currently in New Jersey, so I'm hoping they'll be here in Pennsylvania pretty soon. Once I test them with the power supply and I'm satisfied that the electronics work, I'll complete the enclosure, and at that point, the project will be done. Okay, so I definitely do appreciate any feedback that you have. Certainly anyone who's more expert in power electronics and audio electronics than I am, I would be interested to hear your opinion of what I've done, and if you have any tips on how I should do things. So anyway, thanks for joining in, and I'll see you in the next video.